All right, we got one more method for solving systems of equations, and this is the substitution method. So this one's valuable, especially when both equations are not in that standard form setup where you have like ax plus by equals c. This is often a valuable way to solve a system of equations when you have a variable equal something. For example, in our two equations here, you can see our first equation is just y equals 2x. Our second equation is in that standard form, 7x minus y equals 15. But they're not lined up to eliminate. Now, we could manipulate that first equation if we wanted, and then line them up. But there's another way, and it's called the substitution method. And what we can do in this method is we see that y equals 2x. So that tells us, remember what an equal sign means, whatever's on both sides of it are equal to each other. They're the same. So y and 2x are the same. So anywhere there's a y, I could put a 2x. So what I could do is I could take this 2x and substitute it into the second equation. So I could rewrite this second equation as 7x minus, and in place of that y, I could put a 2x because y and 2x are the same thing. So instead of 7x minus y, I'm going to put 7x minus 2x, and that equals 15 still. So basically, I rewrote that second equation, but instead of the y, I put a 2x. And the great thing about this now is this equation only has one variable. It only has x's in it, which means I can solve it. So I'm going to solve this real quick. On the left side, 7x minus 2x, they're like terms. I subtract, I get 5x. So 5x equals 15. So I can just divide by 5, and x equals 3. And you can see, just like the other, when we did elimination method, I'm halfway to my answer. I know x equals 3. So I can plug it back into either equation. The first one definitely looks easier, y equals 2x. So in place of the x, I can put a 3, so y equals 2 times 3, so y equals 6. And I'm done. I've got my solution. It is 3, 6. My x coordinate is 3, and my y coordinate is 6. So that's the substitution method. So let's look at another. So y equals negative 4x plus 8 is our first one, and y equals x plus 7 is our second equation. So these are both actually in slope-intercept form as the form that they're in. But I could use the substitution method here because I know y equals negative 4x plus 8. So that's saying y and negative 4x plus 8 are the same thing. Then I also know y equals x plus 7. So that's saying y and x plus 7 are the same thing. So this is the same idea as I want you to imagine. What if I said a equals b, and then I said a equals c? So what could you figure out from that? If you know a equals b, and you know a equals c, then that has to mean b equals c. And I can do that same thought process here. If y equals negative 4x plus 8, and y equals x plus 7, then I could plug the negative 4x plus 8 in for the y in this equation, because we know y and negative 4x plus 8 are the same thing. So I could say negative 4x plus 8 equals x plus 7. And then I can solve this equation, because now I have an equation and I only have x's in it. So basically, I rewrote the second equation, but in place of the y, I put a negative 4x plus 8. So I'm going to solve this. I'm going to subtract x. So I get negative 5x plus 8 equals 7. I'm going to subtract 8 here, and I get negative 5x equals negative 1. Divide by negative 5, and I get x equals 1/5. That can happen. You can get fractions. I know most of the problems we've done, that doesn't happen, but it can. You can get a fraction. So I know x equals 1/5. I'm going to take it and plug it into either of the equations. I can do the first or the second one. I'm actually going to pick the second one. The second one looks a little easier. So y equals x plus 7. And in place of the x, I'm going to put a 1/5. So 1/5 plus 7, that would be 7 1/5, but we want our answer to be an improper fraction. Again, we got our calculator to help us out, but that would be, do some math here, 36/5. And now I've got my answer. I know x is going to be 1/5, and y is going to be 36/5. So we've got our answer, and that can happen where you get fractions. All right, let's keep going. So this one, y equals 2x plus 4 is our first equation, and 3x plus y equals 9 is our second equation. So in this one, I know y equals 2x plus 4. Y and 2x plus 4 are the same thing. So what I can do is I could rewrite the second equation, but where the y is, I could put a 2x plus 4, and that still equals 9. So basically, I rewrote the second equation, 3x plus y equals 9, but in place of the y, I put a 2x plus 4. So now I'm just going to solve this. 3x plus 2x is 5x. So 5x plus 4 equals 9. Two-step equation, subtract 4. So 5x equals 5, divide by 5, and x equals 1. And we're halfway to our answer. So all we did was we solved that little equation there. We figured out x equals 1. Now I can plug this back into either equation. I'm just going to pick the first one. 2x plus 4, y equals 2x plus 4. In place of the x, I put the 1. So 2 times 1 plus 4. So I do that math. 2 plus 4 is 6, and y equals 6. So my answer is 1, 6. All right, let's do one more. 2x minus 3y equals -2 is our first equation. Then 4x plus y equals 24 is our second equation. So this one, when you look at it, we could do elimination method, and that's true. This one probably would be easiest to solve with the elimination method. But let's imagine for a moment that you didn't know the elimination method, or the direction specifically said solve with the substitution method, which these do. So what we could do is we could manipulate one of our equations so that it said y equals something or x equals something. When I look at this, it's actually the second equation. If you look at it, 4x plus y equals 24, all I got to do is subtract the 4x. And now this is y equals, I could put I could write it as -4x plus 24, like to put it in slope-intercept form, or you could have written it as 24 minus 4x. It really wouldn't matter for this purposes. So now all of a sudden, instead of being 4x plus y equals 24, it's y equals -4x plus 24, and now I know what y equals. Y equals -4x plus 24. They're the same thing. So then what I could do is, and I'm actually just going to come over here, give myself plenty of room. I'm going to rewrite the first equation. 2x minus 3, but in place of the y, I'm going to put the -4x plus 24. And because 3 is being multiplied by y, I'm going to put it in parentheses. And that equals -2. So I rewrote that first equation, but instead of the y, I put the -4x plus 24. And now I'm going to solve this. So I got to distribute first. Remember, that number in front of the parentheses is being subtracted. So I'm multiplying by a -3. So it'll be 2x plus 12x. -3 times 24 is -72. And that still equals -2. So now I'm going to combine my like terms. So 14x minus 72 equals -2. So add 72. 14x equals 70. Divide by 14, and x equals 5. So halfway to my answer now, I know x equals 5. I can plug this back into any of the equations. I'm actually going to pick the one I manipulated because it's already y equals, and that's what I'm trying to find. So it was y equals -4x plus 24, but in place of the x, I'm just going to put a 5. And now I'm just going to do that math. That'd be -20 plus 24, which is just 4. So I got my answer as 5, 4, with the x-coordinate being 5 and the y-coordinate being 4. All right, that is it for the substitution method.